Hey guys, and welcome back to this video where we're trying to take on topics in physics in like 5 minutes. So specifically, what I want to do here is introduce you to some kinematic equations or some basic equations for one-dimensional motion. So everything we're looking at here is for motion in one dimension, and also again, as it implies, the acceleration is not changing. So one of the most basic fundamental things we can write is this. And I'm going to write velocity is equal to a displacement over time. And you're going to look at this and go, hey, Mr. Cole, in my book it says delta x. Cool. So your book says delta x over delta t. That's awesome. I love books. And so what that means, yes, my whole channel is this dumb. You're right. So what it means is this. Here's the deal, though. Most of the time in every problem, I'm going to say that time initial is 0, which means really the t over here is just T final. And also every problem we assign a coordinate system to. And so for me, I'm going to make my initial position 0 for every problem. What does that do in terms of like saving us time in physics? Well, it means I don't have to do this delta x, xf minus xi every time. So when you see me write x, that is your xf. Now that we've blown a minute on the semantics of physics, let's actually get on with something. So another way you can think about doing an average is take two things, add them up, and divide by 2. That's a very easy way of taking an average. Now, you may already be looking at this going, hey, Mr. Cole, what's V and V sub O? Well, technically, that's V sub 0. And what it is, this is another way of writing. So V is VF, maybe in your book. And my V sub 0 is actually your velocity initial. It's just, I'll be honest, it's a little bit faster notation, and so I'll use it that way. So our other three main kinematic equations are as follows. Velocity final is equal to velocity initial plus A times T. Now notice this, I'm writing X. Oh no, my textbook says delta X. Yeah, aren't we going crazy now? VOT plus 1/2 AT squared. So, Mr. Cole, how come you're writing the X? Again, it means delta X, but my X initial is 0. Have we addressed this? Let's move on. And for my third and final equation, V squared is V sub 0 squared plus 2a delta x. No, I'm just going to write x. This is the Turkford channel, so we're going rogue, plus my chair squeaks. So anyway, we've got kind of a basic idea of what these three sets of equations are. And I'll give you a few little things here as we move on. Every problem I work, and in the next video, we'll actually do examples using these. Essentially, here's how easy these problems are. Every problem you're going to have essentially 5 pieces of information, A, X, T. So for every problem, what I want you to do is this. I want you to look for these variables, and that's what I'll teach you to do. So here's going to be the thing. I'm going to write a big number 3. We're going to call it the rule of 3. I can do any one-dimensional problem as long as I can read it and I can find 3 of the 5 things you see here. Now, you may be looking at this and going, hey, Mr. Cole, what about velocity average? We'll talk about that too later. Usually the problems don't just explicitly give you average velocity. Usually they either give you an initial or a final. So let's move on and do an example in another video and see if we can kind of knock something out here.